I'm going to show you an example of sketching the graph of the form y is equal to the sine of kx or y is equal to the cosine of kx. This method will work whether you're working with sine or cosine. As an example, I'll use the function y is equal to the sine of 2x. So first we're going to determine the period and then we'll sketch the graph of the function. When we determine the period, this will tell us whether or not our function will have a horizontal compression or stretch. We already know that the period of the graph of sine of x is 2 pi. However, when we multiply our input x by a number, such as 2, when we have the sine of 2 of x, we're going to affect the period. So we need to determine the new period. Fortunately, there's a formula that we can use. The period is equal to 2 pi, which is our original period of sine of x, divided by our multiplier k. In this case, k is 2, so we have 2 pi divided by 2 is equal to pi. Pi is our new period. Remember that whenever you have a multiplier of your input, you're going to affect the horizontal stretch or compression. So in this case, we have determined that we have a smaller period than we did before, so we are compressing our curve. Now we're going to graph this curve. We need to plot some points. We already know what the graph of y is equal to sine of x looks like. It's a nice curve with a period of 2 pi. We also know that y is equal to sine of 2x is a horizontal compression of y is equal to sine of x. That's what we just determined by figuring out the new period. So all we need now is to figure out just enough points to where we can make a reasonable sketch of this function y is equal to the sine of 2x. One method that works pretty well is finding quarter points. We divide our interval, that is our period, into 4 equal chunks. So dividing pi by 4, we get pi over 4. So each one of our chunks is going to be pi over 4 in length. And let's lay that out on a number line just for a good visual. So you can imagine this as the x-axis. We've got the 0 at the left. Now if we add pi over 4 to that, that gets us to the end of our first interval. Add another pi over 4, so pi over 4 plus pi over 4 is equal to pi over 2. That's the end of our second interval. Add another pi over 4 to get the end of our third interval, and a final pi over 4 to get to the end of our period. So now all we need to do is find corresponding y values for those numbers that we just found. We'll draw a table using the numbers that we just found as our x values. We plug each x value into y is equal to the sine of 2x to find the corresponding y value. Y is equal to the sine of 2 times 0, which would be the sine of 0, and that is equal to 0. We go on to the next one. Y is equal to the sine of 2 times pi over 4, and 2 times pi over 4 is pi over 2. So the sine of pi over 2 is 1. And do this for the rest of the points. Now we have our x values with our corresponding y values, and all we have to do now is plot those onto our graph. So here's the graph. On the right, you can see the graph of y is equal to the sine of 2x. And all I did was just plot those values that we just found. On the left, just for comparison, is the graph of y is equal to sine of x. So you can see the period of sine of x is 2 pi. So we have one full repeat of our pattern in a length of 2 pi. And on the right, the function that we were just working with, y is equal to the sine of 2x, has been compressed. So the length of the pattern that is going to repeat goes from 0 to pi, so it's only pi in length, so we have a compression. And like I said, you can use the same technique for cosine graphs as well.